Hi everyone, I'm going to discuss arithmetic sequence. So when we say arithmetic sequence, it's a sequence in which each term except the first term is obtained by adding a constant value to the previous term. Now that constant value is we call as the common difference, and we denote that by D. So D is the common difference here. Now, the first term, which is denoted by a sub 1, or the second term rather, which is denoted by a sub 2, is obtained by adding the previous term a sub 1 to the common difference. Likewise, a sub 3 is obtained by adding a sub 2, which is a sub 1 plus d, to the common difference. So we'll have a sub 1 plus 2d here. And generally, in solving for the nth term of a sequence, we consider this general term a sub n equals a sub 1 plus quantity n minus 1 times d. So we always use this formula whenever we solve for the nth term. Now we're going to identify whether each set of numbers is considered as arithmetic sequence or not. For number 1, we consider the numbers as arithmetic sequence, infinite arithmetic sequence, since it has a common difference of 2, and the term is obtained by adding 2 from the previous term. So we consider that as infinite arithmetic sequence. Now, same goes with number 2, as we add the common difference, which is negative 3/4 from the previous term to obtain the next term. So we consider this as arithmetic sequence. Particularly, it's as also infinite arithmetic sequence. But with number 3, now let's change this to square root of 5. The numbers do not form an arithmetic sequence since the consecutive the difference between consecutive terms are different for every pair of consecutive terms. So we do not consider this as arithmetic sequence. So this is not an arithmetic sequence. So how are we going to write the formula for the nth term of the arithmetic sequence with first term 4, second term 14, up to the fifth term 44? So what we're going to do is to construct the required formula. So we need the values of a sub 1, and so we need the values of a sub 1 as well as the value of d. So we have to work on the value of each. Now, using any two consecutive terms here, we can solve for d. So for example, if we're going to use 24 and 14, so we get the difference between the two. So we have 10. So 10 is now the common difference. And we know that the first term here is equal to 4. So substituting the given in the general form, a sub 1 plus quantity n minus 1 times d. And we have a sub n here equals, a sub 1 is 4. And then we have plus, we have 5 terms. So this is 5 minus 1. Then common difference is 10. So we have a sub n equals 4 plus 4, rather we have 4n. Let's work on this one. So we're asked on the general term or a formula or a pattern. So we have here a sub n equals 4 plus this is n minus 1, and then the common difference is 10. So we have a sub n equals 4 plus 10n minus 10. And then we have a sub n equals 10n minus 6. So this is now the general formula for this sequence. Okay, so write the first 4 terms of the arithmetic sequence a sub n equals 5n minus 3. So the required terms of the sequence can be found by simply substituting the corresponding values of n into the given formula. So we solve this problem by finding d of the arithmetic sequence. So we have a sub n here. A sub n equals a sub 1 plus quantity n minus 1 times d. So we have here so we have a sub 1 equals so we have a sub 1 equals this is 5 times 1 minus 3. So we have a sub 1 equals 5 minus 3, so we have 2. And then for a sub 2, we have 5 times 2 minus 3. So we have a sub 2 equals 10 minus 3 here. So we have 7. Now take note that between a sub 1 and a sub 2, the difference is 5. Since this is a sequence, what we will just do is to add 5 from a sub 2 to obtain a sub 3. So this is 7 plus 5. So this is 12. While a sub 4 is 12 plus 5. So this gives us 17. So the first 4 terms are 2, 7, 12, and 17. Okay. Find the 10th term of the arithmetic sequence whose first term is -2 and whose fifth term, or rather 10th term, is 10. So we solve this problem by finding the common difference of the arithmetic sequence. So we solve that by working on the value of d. So we have, so solving for d, we can consider a sub n equals a sub 1 plus quantity n minus 1 times d. And then we have our a sub 5 here equals a sub 1 plus 5 minus 1 times d. And we know that the fifth term is 10, while the first term is -2. And then this is equal to 4d. Now we have 4d equals 12. So dividing both sides by 4, we have d equals 3. Now that we found d, we can solve for a sub 10. So a sub 10 is equal to a sub 1 is -2, and then plus this is 10 minus 1 times 3. So we have a sub 10 equals -2 plus this is 9 times 3. Okay, 27. So a sub 10 class is 25. There. Now, the arithmetic means of two numbers is a set of values which form an arithmetic sequence with the given numbers. Now, in such numbers, the arithmetic means is always specified. If only one arithmetic mean is required, then it is the average of the given numbers. So, for example, find 3 arithmetic means between -5 and 19. So, we're asked to find 3 values in between -5 and 19. So, what we're going to do here, by definition, the arithmetic mean should form an arithmetic sequence along with the given number. So, this means that the sequence will have 5 terms. So, this is the first term, then we have 3 terms in between, and then the fifth term, 19. Okay, so we have a sub 1 equals -5, and a sub 5 equals 19. Okay, and then we can use this information to solve for D. So we have a sub n equals a sub 1 plus n minus 1 quantity D. So we substitute 19 here equals -5 plus, so this must be 4D. So we have 4D here equals 24. So dividing both sides by 4, we have D equals 6. Finally, we can use D to obtain the required arithmetic means. Thus, we can come up with a sub 2 here. Since a sub 1 is -5, we'll just add 6. So a sub 2 is 1. And then for a sub 3, so we'll just add 6. So 1 plus 6 is 7. While a sub 4, we'll just add 6 to 7. So we have 13. So as we add 13 to 6, we'll get 19. So this is the fifth term. And then the first term is -5. So the 3 arithmetic means are, we have 1, 7, and 13. Okay. Now, how do we define an arithmetic series? So an arithmetic series is the sum of the terms of an arithmetic sequence written as a string of terms connected by addition signs and subtraction signs when necessary. So we have the terms 1 plus 3 plus 5 plus ... plus 53 form an arithmetic series whose common difference is 2. The infinite series -4 plus 6 plus 16 plus 26 plus ... is also arithmetic sequence with a common difference of 10. Okay. And then the series 1 -2 plus 8 minus 2 plus ... is an arithmetic series because the difference between consecutive terms varies for every pair. I mean, this is not an arithmetic series. Okay. So how do we work or calculate for the sum of the finite arithmetic series? So this is denoted by S sub n equals n times quantity a sub 1 plus a sub n all over 2, where n here is the number of terms, while a sub 1 is the first term. A sub n will be the last term. Okay. So the sum of finite arithmetic series can be evaluated, and we call this as convergent, while the sum of infinite arithmetic series cannot be evaluated, and this time we call this as divergent. For the first example, we're asked to find the sum of all integers between 15 and 150, which are multiples of 7. So we have to find out as to what will be the first term and what will be the last term. And the rule here is it has to be multiples of 7. Okay? So to obtain the value of n, so first we have to evaluate the sum. We need to find the values of n, a sub 1 and a sub n, because in the formula, it's necessary that we identify each of these terms for us to evaluate the sum of all integers between 15 and 150, which are multiples of 7. Then to find a sub 1 and a sub n, we take the smallest and largest multiples of 7 definitely in the given interval. And these are 21 and 147 respectively. Now, to obtain the value of n, we simply subtract a sub n minus a sub 1. And then we divide the answer by 7 and we will add that by 1. So n here is equal to 147 less 21, and then we divide that by the common difference d, and then we add 1. So we have 19. So we know that n is 19, and then we have a sub 1 equals 21, a sub n equals 147. So we can solve for the sum of the 19 integers. And we have 19 times quantity for 21 plus 147 all over 2. So this is equal to 1,596. Okay. So the second example is finding the sum of all even numbers rather, from 40 to 400. So again, we need to work on the values of n, a sub 1, and a sub n. Now, we have to satisfy that each value must be even numbers. Since 40 is an even number as well as 400, then we can say that a sub 1 is 40, while a sub n is 400. And we need to work on n. Again, n equals a sub n minus a sub 1 all over the common difference plus 1. So we have n equals 400 less 40 all over 2 plus 1. So our n here is equal to 181. So we have 181 even numbers here from 40 to 400. So we can now solve on the sum of these 181 even numbers. And we have 181 quantity 40 plus 400 all over 2. So all in all, we have 39,820. Okay, so in our discussion, we were able to define what's an arithmetic sequence. We were able to distinguish an arithmetic sequence from a non-arithmetic sequence. And then we work on arithmetic means, arithmetic series. So finite arithmetic series are convergent while infinite are divergent. So to summarize, an arithmetic sequence is a sequence in which each term except the first is obtained by adding a constant value to the previous term. The common difference of an arithmetic sequence is the difference between two consecutive terms. The arithmetic means of two numbers form an arithmetic sequence with the given numbers. If the first term of an arithmetic sequence is represented by a sub 1 and its common difference is given by d, then its nth term can be found using the formula a sub n equals a sub 1 plus quantity n minus 1 times d. Then the sum of a finite arithmetic series is the first term a sub 1 and nth term a sub n is given by this formula. Finally, all infinite arithmetic series are divergent. So next meeting, I'm going to introduce another lesson. So that's it for now.